In the span of 4 days, one of the most powerful rivers on Earth effectively stopped. Not slowed, not dipped. Stopped, at least in any meaningful sense of the word. Water levels across multiple monitoring stations along the Amazon River dropped by 62% in 96 hours. Scientists watching the data in real time describe the readings as, and I'm quoting here, outside the range of anything we've modeled. Boats that had navigated the same channels for decades ran aground on riverbanks that hadn't seen open air since the last ice age. Communities that depend entirely on river access for food, medicine, and communication were suddenly cut off. Not by flood, not by storm, but by the shocking, terrifying absence of water. And then, in the cracked mud and exposed sediment of the newly revealed riverbed, researchers found something that stopped everyone cold. Structures, stone formations, the unmistakable geometry of human construction, built, according to initial radiocarbon estimates, approximately 12,000 years ago. The Amazon had been hiding an entire civilization beneath its surface, and it took one of the most alarming environmental events in recorded history to expose it. That tension, between catastrophe and discovery, between loss and revelation, is exactly what makes this story so impossible to look away from. Because what's happening in the Amazon right now isn't just a weather event. It isn't just a drought. It's a signal. And if we understand what that signal is actually telling us, the implications reach far beyond Brazil, far beyond South America, and into the future of the entire planet. So let's talk about what actually happened, what scientists found, and what it might mean for all of us. Most people understand the Amazon as a rainforest, but that framing undersells it. This is a planetary life support mess, chainism hiding in plain sight. The Amazon River Basin covers approximately 7.4 million square kilometers. To put that in context, that's roughly the size of the entire continental United States. The river system itself carries more fresh water to the ocean than the next 7 largest rivers on Earth combined. At peak flow, the Amazon discharges around 209,000 cubic meters of water per second into the Atlantic, a volume so enormous that you can detect the freshwater plume in satellite imagery hundreds of kilometers offshore. The forest that surrounds the river isn't just scenery. It's a living engine. The Amazon generates something researchers call flying rivers, massive atmospheric moisture corridors produced by evapotranspiration from the canopy. The trees essentially pump water from the soil into the sky, where it forms clouds that then travel thousands of kilometers, delivering rainfall to agricultural regions across South America, including the breadbasket provinces of southern Brazil, parts of Argentina, and portions of Bolivia. Scientists at Brazil's National Institute for Space Research, INPE, have estimated that these flying rivers carry as much water as the Amazon River itself. When the forest weakens, when the river falters, that entire moisture system destabilizes, and the ripple effects show up in crop yields, reservoir levels, and rainfall patterns across a continent. Approximately 30 million people live within the Amazon basin. That includes hundreds of indigenous communities, many of which have maintained continuous habitation in the region for thousands of years. It includes major cities. Manaus, a city of over 2 million people, sits at the confluence of the Amazon and the Rio Negro, and its economy, its food supply, its very existence is engineered around the assumption that the river will be there. When it isn't, everything built on top of that assumption begins to crack. And this region has been cracking with increasing frequency. The 2005 drought was called a once-in-a-century event. Then 2010 was worse. Then 2015 to 2016. Then 2021. Each time, scientists documented new benchmarks, lowest water levels ever recorded, most extensive dry season ever measured, most widespread fishing and agricultural disruption in living memory. And now this, a 62% drop in 96 hours that blew past all of those previous benchmarks like they weren't even there. What makes this particular event unprecedented isn't just the scale of the drop, it's the speed. River systems of the Amazon's size don't behave this way under normal hydrological patterns. The speed of this decline is, in the words of hydrologists monitoring the event, deeply anomalous. And that anomaly is what elevated this from a drought story to something more urgent. To understand why a 62% drop in 96 hours is so deeply alarming, you first need to understand how river systems like the Amazon actually function under normal conditions. Rivers don't simply collect rain and push it downstream. They're dynamic, interconnected systems. Part surface hydrology, part groundwater interaction, part atmospheric feedback loop. The Amazon in particular operates through a cycle that's almost biological in its complexity. During wet season, which typically runs from December through May, the river expands dramatically. At peak flood, it inundates an area larger than France. Fish migrate into the flooded forest. Nutrients flow from the canopy into the water. Sediments deposit across the floodplain, enriching soils that communities have farmed for generations. Then, as dry season approaches, the river retreats, gradually, predictably, along patterns that have been stable for thousands of years. The key word there is gradually. River systems have what hydrologists call residence time, the amount of time water spends in a system before exiting downstream. For the Amazon, that residence time creates natural buffers against sudden fluctuation. Even during severe droughts, the river's sheer volume, the groundwater inputs from hundreds of tributaries, and the moisture cycling capacity of the surrounding forest have historically prevented the kind of rapid, cliff-edge decline that monitoring stations just recorded. So when you see a 62% drop in 4 days, you're not seeing a natural drought progression. You're potentially seeing multiple reinforcing systems fail simultaneously. Here's the first piece. Atmospheric researchers at the University of São Paulo have documented a significant disruption in the Amazon's flying river system over the past 18 months. The evapotranspiration rates. That's the process by which trees pull water from the ground and release it into the atmosphere, have measurably declined in deforested and degraded zones. When that moisture doesn't make it into the atmosphere, it doesn't come back as rainfall. The forest, in parts of the eastern and southern Amazon, has begun what researchers describe as a transition from moisture source to moisture sink. It's absorbing what little rain falls rather than generating more. That's a feedback loop. A self-reinforcing cycle that, once established, becomes extremely difficult to reverse. The second piece involves sea surface temperatures. The tropical North Atlantic has been running abnormally warm. In some monitoring zones, more than 1 degree Celsius above the long-term average. That sounds small. It isn't. Ocean temperature anomalies of that magnitude shift the intertropical convergence zone, the band of atmospheric convection that drives rainfall patterns across much of South America. When that zone migrates, rainfall that normally falls over the Amazon basin gets redirected. The moisture still exists in the atmosphere. It just doesn't land where it's supposed to. The third piece is the one that keeps climate scientists up at night. Cumulative forest loss. INPE's satellite monitoring data indicates that the Amazon has lost somewhere between 17 and 20% of its original forest cover. Research published in the journal Nature has suggested that the tipping point, the threshold beyond which the Amazon can no longer sustain its own moisture cycle and begins transitioning to a drier, savanna-like ecosystem, could lie somewhere between 20 and 25% deforestation. We may be, right now, within striking distance of that threshold. And the critical problem is that we wouldn't necessarily know we'd crossed it until we were already well past it. Scientists can't predict exactly when or whether any specific tipping point will be reached. That uncertainty is important to acknowledge honestly. Ecological systems are non-linear, and there are stabilizing feedbacks we may not fully understand. But the directional signals, the trend lines, the anomaly readings from this specific event, all of them are pointing in the same direction. And that direction is not reassuring. Now, here's where it gets even more complex. Groundwater. The Amazon sits atop one of the largest freshwater aquifer systems in the world, the Alto do Chão aquifer, which underlies a substantial portion of the central Amazon basin. Under normal hydrological conditions, the river and the aquifer interact dynamically. During wet season, the river recharges the aquifer. During dry season, groundwater seeps back into the river, helping sustain flows even as rainfall declines. It's a balance, a partnership, almost. What researchers monitoring this event have noted is that the groundwater contribution, what hydrologists call base flow, appears to have dropped sharply this season. The aquifer isn't giving back what it should. Whether that reflects long-term depletion from agricultural extraction, reduced recharge from the previous wet season, or some other factor isn't yet fully confirmed. But the implication is significant. If the river's groundwater buffer has weakened, then future droughts won't just be driven by atmospheric conditions, they'll be amplified by the loss of that underground reserve. The backup system is failing. That's the science beneath the headline, and understanding it makes what happens next in this story both more astonishing and more sobering. And then came the discovery that nobody expected, the one that turned a climate catastrophe into something that felt almost archaeological. As water levels retreated across the middle and upper stretches of the Amazon, exposing riverbed sediments that had been submerged for as long as anyone could measure, researchers and local community members began documenting what the receding water left behind. Fallen trees, yes, beached river dolphins, the bleached skeletons of fish, but also something else, something geometric, something deliberate. Near the confluence of the Solimões River, one of the Amazon's major tributaries, local fishermen first noticed what they described as stone walls emerging from the sediment. The formations were too regular to be natural, too organized. The alignment suggested deliberate construction, stones placed with intention, not deposited by current or geological process. Word reached researchers at the Federal University of Amazonas quickly, and within days, a preliminary survey team was on the ground. What they documented, and again, these are early findings, still subject to rigorous peer review and further excavation, were the remnants of what appears to be a large, organized settlement. Platforms, possible earthworks, stone arrangements consistent with what archaeologists recognize as deliberate landscape modification by complex, pre-Columbian societies. The radiocarbon dating on organic material recovered from the sediment layers directly associated with the formations suggests an age of approximately 12,000 years, placing the construction during the late Pleistocene, right at the transition into the Holocene era. That's the period immediately following the last ice age, when human populations across the Americas were still largely categorized as nomadic hunter-gatherers, or so we thought. Because here's what makes this discovery so significant in a scientific context. For decades, the dominant academic narrative held that the Amazon basin's dense, acidic, nutrient-poor soils made permanent, large-scale settlement essentially impossible before significant technological development. The pristine wilderness model of Amazonia held that the forest was essentially untouched, that the Amazon we see today is what the Amazon has always been. That model has been eroding for years, challenged by discoveries of terra preta, the dark, anthropogenic soils found across the basin that indicate extensive, sophisticated land management by ancient peoples. It was further undermined by LiDAR surveys, that's light detection and ranging technology, essentially aerial laser scanning that can see through forest canopy, that began revealing geometric earthworks, road networks, and settlement patterns beneath the trees. But this discovery, if confirmed, pushes that timeline back dramatically. 12,000 years is not a minor revision to the archaeological calendar. It means that human beings were constructing organized settlements in the Amazon, while woolly mammoths were still walking the earth. It means the Amazon was not a wilderness waiting to be discovered, but a landscape that has been shaped, managed, and inhabited by human intelligence for an almost incomprehensible span of time. Dr. Ana Claudia Torres, an archaeologist with the University of Brasilia, who was part of the initial survey team, described the moment the formations became visible as, and this is her language, like watching the river hand something back. There's something almost poetic in that framing. The Amazon, stressed beyond precedent, retreating from its banks in an alarming display of climatic dysfunction, simultaneously pulling back a curtain on human history that no one knew was there. The irony cuts deep. The same drought that may represent one of the most serious ecological warning signals in living memory has given us a window into a civilization that understood this landscape in ways we're only beginning to appreciate. What did those ancient inhabitants know about managing water, managing forest, managing soil? What systems did they build that allowed complex settlement in an environment that conventional archaeology said couldn't support it? And what happened to them? What ended their cities, silenced their communities, returned their stones to the riverbed? Those questions matter beyond academic curiosity. They matter because if people once thrived in the Amazon through sophisticated ecological management, then the idea that the Amazon is too wild, too complex, too fragile for human habitation is exactly backwards. and understanding how they did it might tell us something crucial about what we're doing wrong now. Brazil's National Water and Basic Sanitation Agency, the ANA, along with INPE, Brazil's National Space Research Institute, has been tracking water level anomalies in the basin for months, and the picture emerging from their monitoring network is, to put it plainly, deeply concerning. ANA operates a network of over 2,000 hydrological monitoring stations across the Brazilian river system. In the weeks leading up to the rapid decline event, multiple stations in the central and upper Amazon basin were already registering levels in the bottom 10% of their historical ranges for the time of year. That context matters, because the 62% drop didn't occur from a healthy baseline. It accelerated from a starting point that was already stressed. The current alert status in affected areas of the Amazon basin sits at what Brazilian authorities classify as a critical water shortage alert, the highest tier in their emergency response framework. Several municipalities in Amazonas state have formally declared drought emergencies, unlocking federal disaster relief provisions. In the city of Manaus, port operations have been severely restricted as water depth in key navigation channels dropped below minimum safe thresholds for commercial vessels. That has direct consequences for supply chains, for food, fuel, and medical supplies that river communities depend on entirely because roads simply don't exist in much of the basin. The Brazilian Navy has deployed river vessels to conduct humanitarian operations in isolated communities, delivering water, food, and emergency medical support to populations that can no longer be reached by commercial transport. INPE's satellite imagery has documented cattle dying in the flooded, or rather formerly flooded, agricultural areas that border the forest, as water sources that livestock depend on have simply vanished. What's notable from a policy standpoint is that the warnings were not absent. Scientists at INPE had published drought probability forecasts flagging elevated risk for the 2025-2026 dry season as early as mid-2025, citing the warm Atlantic sea surface temperatures and reduced dry season rainfall trends in prior years. The World Meteorological Organization had included the Amazon basin in its regional drought early warning bulletins. The signals were there. What hasn't always matched the warning level is the speed and depth of the institutional response. Emergency preparedness in the Amazon faces unique structural challenges that are worth acknowledging honestly. The basin's geography, vast, remote, dependent on river infrastructure that is itself compromised by the drought, makes rapid humanitarian response genuinely difficult in ways that aren't true of droughts in other regions. There are communities accessible only by boat or small aircraft. There are indigenous territories with hundreds of residents whose nearest town, under normal conditions, is a 2-day river journey. Under current conditions, that journey may simply not be possible. International scientific institutions, including NASA's Terrestrial Hydrology Program and the European Space Agency's Earth observation systems, have both turned monitoring resources toward the basin, providing real-time data updates that are feeding into the response effort. But monitoring data and on-the-ground capacity to act on that data are very different things. Gaps remain, and in those gaps, people are suffering consequences that were, to some degree, foreseeable. Here's where scientists and climate modelers start using language that should make everyone pay attention. Terms like tipping point, irreversible threshold, and dieback cascade. Let's be careful with language here because precision matters. No credible scientist is predicting that the Amazon will disappear or that a specific threshold will be crossed at a specific date. The science doesn't support that kind of certainty, and anyone telling you otherwise is stepping beyond what the evidence actually shows. What the science does support, what the modeling and the monitoring data both point toward, is a range of conditional scenarios that become more probable as the stress on this system increases. Scenario 1. A prolonged, severe drought season that resolves in the next wet season without triggering permanent hydrological change. This is still a likely outcome for the immediate situation. River systems are resilient. Wet seasons in the Amazon can be powerful recovery events, and if the atmospheric drivers that produced this anomaly shift back toward historical norms, the river could recover substantially within months. The archaeological sites, however, would return to submersion, and whether they were adequately documented before that happens depends entirely on how quickly researchers can deploy. Scenario 2. A partial recovery that leaves the system in a persistently degraded state. This is the scenario that climate scientists consider most probable given current trajectories. In this scenario, the wet season brings rainfall that is below historical average, groundwater recharge remains incomplete, and the Amazon enters the next dry season already compromised. Year by year, the baseline drops. The extreme events that used to be anomalies become the new normal. Fish populations that didn't recover from this season don't recover the next. Fishing communities that were already marginal economically become unsustainable. Scenario 3. And this is the one that lives in climate models as a genuine concern, even while remaining deeply uncertain, involves what researchers at the Stockholm Resilience Center have described as an Amazon dieback, a transition driven by crossing the deforestation and drying threshold in which large portions of the eastern and southern Amazon undergo an irreversible biome shift from tropical rainforest to cerrado-type savanna. Research published in Nature Climate Change has suggested that if such a transition were to occur, it could release between 90 and 140 billion tons of carbon into the atmosphere, roughly 10 years of total global emissions at current rates. It would effectively flip the Amazon from a carbon sink, something that absorbs carbon dioxide and moderates climate, to a carbon source. The implications of that cascade extend globally. The Amazon's role in regional precipitation extends to the agricultural systems that feed hundreds of millions of people across South America. The loss of that precipitation regulation could, models suggest, affect crop yields in Argentina, Uruguay, Bolivia, and southern Brazil, regions that are significant contributors to global food supply. This is not a localized environmental story. It is a potential node of global systemic risk. And here, the ancient civilization discovered in the drained riverbed becomes relevant in a different, more urgent way. Those structures, those stone platforms, those earthworks, those organized formations exist as evidence that this landscape supported complex, organized human life for thousands of years. That stability wasn't accidental. It was managed, deliberately, intelligently. Whatever those ancient inhabitants knew about living in balance with this ecosystem, we have lost that knowledge almost entirely. We're operating in a landscape we barely understand, pulling on threads whose connections we can't fully map, and the monitoring data is telling us that some of those threads are fraying. Two things can be true simultaneously. This drought is a warning signal that demands serious attention, and the civilization it revealed is one of the most extraordinary archaeological finds in recent memory. Let's hold both of those things at once as we step back from the data, because I think that's actually the most honest way to end this conversation. The Amazon crisis is real, the monitoring is clear, the trend lines are alarming, and the human consequences, the isolated communities, the dying fish, the stranded boats, the children without clean water access. Those aren't abstractions. They're happening right now, to real people, in real communities, with real names. The science that underlies the concern isn't speculative or contested at its core. The Amazon is under extraordinary stress. That stress is both climatically and anthropogenically driven. And the window for changing the trajectory, while not closed, is narrower than it's ever been. But the 12,000-year-old civilization lying beneath the waterline is also real, and it carries a message that's genuinely hopeful if we're willing to hear it. Human beings lived here, thrived here, built here, not for a generation or two, for millennia. They understood something about how to inhabit this place without destroying it. That knowledge didn't survive in written form, but it survived in the soil, in the terra preta, in the earthworks, in the geometry of stone that a retreating river just handed back to us. We have the tools now, LIDAR, isotope analysis, soil chemistry, genetic archaeology, to begin reading that knowledge, to begin understanding what sustainable civilization in the Amazon actually looked like. That matters, not as a feel-good coda to a frightening story, but as a genuine scientific resource. If we want to imagine what a human future in the Amazon could look like, one that doesn't end in dieback and displacement, we might start by looking more carefully at the human past. The river will rise again, wet season will come, the formations will likely return to the deep. Whether we've learned anything from the moment they surfaced, that is the question that will define what happens next. If this story matters to you, the most useful thing you can do right now is stay informed. Follow the work coming out of ENPE, out of the Federal University of Amazonas, out of the international research teams now focused on this site. Support organizations working on sustainable Amazon policy. And if you're the kind of person who thinks about these systems, because people who watch content like this tend to think carefully about interconnected problems, share this, not to alarm people, but to make sure they understand what's actually at stake. Because the Amazon isn't a distant wilderness, it's a heartbeat. And right now, that heartbeat is irregular in ways that deserve every serious mind we can bring to bear on it. What we uncovered this week could rewrite everything we thought we knew about human history in the Americas. Next time, we're going deep on the LiDAR discoveries that have been quietly reshaping the archaeological map of the Amazon basin for the past decade. Earthworks, roads, cities hidden under the canopy, waiting. What's already been found is extraordinary. What's still out there may be even more so. Stay curious, stay informed, and don't look away.